Hello, guys. Welcome to Ramta Solutions. Welcome to your lesson on probability. Today, we are looking at arrangement of objects in a row. So, this is nothing new. We have somehow introduced this aspect in the video on factorial notation. I think it was video 13. Yes, it was video 13. Okay. So, in that video, we asked you how to find, or we asked you to find the total number of outcomes when arranging objects. Now, in this object, we're going to explore that aspect of arranging objects in a row. Okay, we are going to explore it further. So now, consider a group of 3 boys and 2 girls sitting in a row at a cinema. And then the questions would be, how many ways can the 3 boys and the 2 girls sit? So check this out. We have 3 boys and 2 girls. Together, this makes 5, right? Together, this makes 5 people. Okay, together, this makes 5 people. So the first question says, how many ways can we arrange the 3 boys and the 2 girls, or how many ways can the 3 boys and the 2 girls sit? It's easy. Number A, they are 5. So this is in 5 factorial ways. Remember, 5 factorial is 5 times 4 times 3 times 2 times 1. Why are we saying that? It doesn't matter who sits first. It's a boy or it's a girl. It doesn't matter. But if one of them sits, we are left with 4 people for the second seat. One of the 4 seats, we are left with 3 for the second. For the fourth seat. If one of the 2 seats, we are left with 1 for the last seat. Okay. So what is this? 5 factorial, and we see 20 times 3. 60, so it's 120, but let me confirm. 5 factorial, take your calculator, guys. 5 factorial, it's 120. So there are 120 ways in which we can arrange these boys and girls. Okay, there are 120 ways in which we can arrange these boys and girls. Okay, so we are done with number A. Number B says, how many ways can they sit in a row if a boy and his girlfriend must sit together? And kids, please, there are no girlfriends at this time. You're still at school, eh? Okay, so we're going to look at it. So number B, we will say, let's say we have boy 1, boy 2, boy 3, and then we have girl 1, girl 2. Let's say boy 1 and girl 2 are these boyfriend and girlfriend, right? Let's say these 2 are our couple. Should we call them a couple? Yeah. Let's say these 2 are our couple. Okay. Now, what we are saying, there are 2 ways in which you can arrange them, right? The boy could sit on the left and the girl on the right, or the girl could sit on the left and the boy on the right. Okay, and the boy on the right. All right. So, in other words, there are 2 to arrange the couple. To arrange the couple, we need 2 factorial ways. All right. There are 2 factorial ways. Now, again, I want you to note this. The question is not saying that the couple must sit at the edge or at the second seat or wherever. It says they must be together. So since these couples must be together, I will call them couple. And what are we left with? We are left with boy 2, boy 3, and girl 2. Can you see that? So what does it mean? it means now we are left with 4 people. All right, it means now we are left with 4 people. Now, arranging 4 people, okay? I'm saying people because I'm now considering the couples as a unit, okay? Arranging 4 people. Remember, when we arrange 4 people, for the first seat, one of the 4, which is the couple, can sit, or one of the boys can sit, or one of the girls, it doesn't matter. One of them can sit. For the second, one of them can sit, just like that, right? Just like that. So to arrange these 4 people, which ones? These ones here. What do we need? We need 4 factorial ways, right? We need 4 factorial ways, okay, to arrange these 2. But remember, this is not just it. So what we need to do now is this. Okay, we have arranged these 2. So generally, therefore, to arrange these boys and girls, when a boy and his girlfriend are seated together, we will need 2 factorial ways to arrange them, the couple, multiplied by 4 factorial ways to arrange this whole group. So get your answer. What is your answer? 2 factorial multiplied by 4 factorial. So this is 48 ways of arranging them. Okay, this is 48 ways of arranging them when the boyfriend and the girlfriend are seated next to each other. To help you understand this question, what I'm saying, we do know that indeed it is 5 seats. Okay, it's 5 people, we know, but wherever boy 1 and girl 1 are seated, one must be next to the other. Okay, it doesn't matter if this one is seated on, say, seat 2 or seat 1. The other must sit immediately next to their partner. Okay, the one must sit immediately next to their partner. So I'm going to, because taking 5, 5 is a big number. I'm going to take, but I did this in the previous video. I'm going to take, say, 4, as an example. I'm going to expand on this because it's important that you see this, okay? So as an example, let's remember, I'm pausing a bit on this question. So I'm saying let's consider family of 4, including father, mother, daughter, and son. Okay, father, mother, and son. So now let's say father and mother sit next to each other. I want you guys to look at this. According to what we did in the previous video, it will be father and mother are 2 people. We can arrange them in 2 factorial ways, right? We can arrange them in 2 factorial ways. Now, they will then become a unit. When they become a unit, we will then have a unit of parents and daughter and son, which is 3 people left, which will be, let's get it, which will be 2 factorial times, I think it's 6, which is 12. It'll be 12 ways, all right? It'll be 12 ways. 12 ways when mother and father sit next to each other. Now, let us show you this manually. So, this is father, mother, daughter, son. Father, mother, son, daughter. Okay? And then I'm going to take, let me say daughter, father, mother, son. Daughter, mother, father, son. Can you see that? Now let's take son, father, mother, daughter. Son, mother, father, daughter. Can you see that? Can you guys see that? Perfect. Now let's then say, we then say son, daughter, mother, father, son, daughter, father, mother. Okay? Then daughter, son, mother, father. Daughter, son, father, mother. And what else do we need to look at? Let me see. Okay. 4, 8. So we need 4. Now, father, mother, daughter, son. Okay, sorted. Okay. And now, what else do we need to look at? What else do we need to look at? Okay. Father, mother, daughter, son. It's okay. Father, mother, son, daughter. Daughter. Okay. Daughter, father, mother, son. Daughter, mother, father, son. Okay. All right. Okay, perfect. So let's see what else we need to do. Daughter, son, mother, and father. We're done. I am not sure, but there is something that I also need to look at. So, okay, let's see. I'm not sure, but there must be something that's missing. I think we are done here. This is fine. Oh, this is fine. Okay, this is fine. Okay, this is fine. Oh, maybe I should have. Okay. Let me do this. I'm going to redo this quickly. I'm going to redo this quickly. I'm not sure. Let me see. I'm going to use a different color. This father, mother, daughter, son is fine. Father, mother. Oh, okay. I now see what I have to do. What's missing is this. It's mother, father, daughter, son. Mother, father, son, daughter. That's the one that's missing. Can you see that? Now I'm going to highlight this. I'm going to highlight parent. Okay, I'm going to highlight parent. Underline rather parent. Okay. Now I want you to see this. Wherever they may be, one is sitting exactly next to the other. Can you guys see that? So how many ways are here? 1, 2, 3, okay, 6. These are 12 ways. Okay, so these are 12 ways. Can you guys see that? These are 12 ways. Okay, these are 12 ways. So this formula is working. Okay, so this is how we got to it. Okay, this is how we get to it. So this formula, instead of using this, it'll help you a great deal. Okay, perfect. Now, we were able to find this and we are content. Now let's go to the next question. The next question says, in how many ways can they sit if the boys and the girls are each to sit together? Meaning boys sit as boys and girls sit as boys. Okay, let's go. Okay, let me do this. I need an extra copy for boys. For this one here, I need an extra copy. Please hold. Okay. How many questions? Let me erase this because I don't want to start on a blank page. Let me erase this. Okay. Let me see. I need, okay, I'm gonna make an extra one. Okay, also copy this. Perfect. Okay, so this question says, it says that how many ways can they sit if the boys and the girls are each to sit together? Again, we're going to look at this. We will say 1, the boys are to sit as boys. So how many boys do we have? For boys, how many boys do we have? We have 3 boys. So it will be 3 factorial way of choosing the boys. For the girls, we have 2 girls, right? So there are 2 factorial ways of choosing the girls, right? So that therefore means for us, we have one, let me say we have boys and we also have girls, which means a group of girls could start on the left or on the right. So there are 2 factorial ways of grouping this unit of boys and girls. Okay, so Now, when we solve this, we will say this is 1, 3 factorial ways for the boys to sit, 2 factorial ways for the girls to sit, times 2 factorial ways for the group of boys and the group of girls to sit. What's your answer? I see it to be 24. I see it to be 24. So let's see. 3 factorial times 2 factorial times 2 factorial, which is 24 ways. All right? Which is 24 ways. All right? It's 24 ways in which these boys and girls could sit. So I'm going to do this example again. Remember, I am content with this, but I'm just showing you when you are uncertain what you need to do. So remember, we have boys 1, 2, 3, and so on. So this is boy 1, boy 2, boy 3, and then girl 1, girl 2. This is boy 1, boy 2, boy 3, and then girl 2 or girl 1. We have boy 1, okay? Let me say boy 2, not boy 1. We have boy 2, boy 1, boy 3, and then girl 1, girl 2. Boy 2, boy 3, okay, no, boy 2, boy 1, boy 3, girl 2, girl 1. Boy 2, no, this time I'm taking boy 3. Boy 3, boy 1, boy 2, girl 1, girl 2. Boy 3, boy 1, boy 2, girl 2, girl 1. Already I can see this will be a mess. All right, already I can see this will be a mess. Okay, now I then go to boy 1, boy 3, boy 2, girl 1, girl 2. Boy 1, boy 3, boy 2, girl 2, girl 1. Can you see? I'm only changing the girls for now. Then let me proceed and say boy 2, boy 3, boy 3, boy 3, boy 1, and girl 1, girl 2. Boy 2, boy 3, boy 1, girl, my mistake here. Girl 2, right? Girl 2, girl 1. Now, boy 3, and then boy 2, boy 1, girl 1, girl 2. And then what? Girl, boy 3, boy 2, boy 1, girl 2, girl 1. You see, this is the arrangements that are possible for the boys. Now let's go to the girls, and I see we have 12. So we can have girl 1, girl 2, boy 1, boy 2, boy 3. We can have girl 1, girl 2, boy 1, or boy 3, boy 2. Right? Boy 2. Again, we can have, my mistake. Let me fix this. So this is tedious, guys. Remember, I said it's important to have formulas. One of the reasons you are doing mathematics is to avoid doing this and just do this. Okay, so we have girl 1, girl 2. Let's see. Boy 2, boy 1, boy 3. Girl 1, girl 2, boy 2, boy 3, boy 1. Girl 1, girl 2, boy 3, boy 1, boy 2. Girl 1, girl 2, boy 3, boy 2, boy 1. Okay? Again. What else do we need? Girl 2, girl 2, girl 1. Girl 2, girl 1, boy 1, boy 2, boy 3. Girl 2, girl 1, boy 1, boy 2, boy 3. girl 2, girl 1, boy 2, boy 1, boy 3. Again, girl 2, girl 1, boy 2, boy 3, boy 1. Again, boy, girl 3. Oh boy, we don't have 3 girls, we have 2 girls. So girl 2, girl 2, girl 1. What is this? Boy 3, boy 1, boy 2. Girl 2, girl 1, boy 3, boy 2, boy 1. This is it. When you look at it, this is 1, 2, 3, 4, 5, 6. This is 12. 1, 2, 3, 4, 5, 6. This is 6. This is 6. So together, this is 24. Do you see that? So these are 24 ways in which a group of boys can sit together and a group of girls can sit together. I hope you guys now get to appreciate this. Okay? Perfect. Moving on. So number D. Now, in how many ways can they sit if only the girls can sit together? So now I no longer need to do that manual calculation. If the girls sit together. Okay, so if the girls sit together, this is D. Let me do this. Okay. In case. So if the girls sit together, one, we have 2 girls, right? We have 2 girls, all right? And then if we have 2 girls, we will consider the girls to be a unit. And then we have 3 boys. Now, this means we have 2 ways of fixing the girls, but this unit of the girls together with the 3 boys will become 4, all right? Will become 4. And this is how we solve this. So our answer is simply 2 factorial. This must be 48. Let me see. 2 factorial times 4 factorial. What is it? Indeed, it's 48 ways. Okay? So these are 48 ways that the girls sit together. All right? 2 factorial, 48 factorial ways that the girls can sit together in this group. Okay? Perfect. Now number E, if the boys sit together. I think let me do this. Number E, boys sit together. Boys sit together. Okay? Here was supposed to be girls sit together, but it's okay. So how many boys do we have? We have 3 boys, right? If we have 3 boys, we have 3 ways of arranging these boys. Now, boys are now becoming a unit. However, we have 3 girls. So, we have 2 girls. So, the unit of boys and the 2 girls together will become 3. So, it'll be 3 times 3. So, this is 6 times 6 must be 36. Let me confirm. 3 factorial times 3 factorial. Yes, it's 36 ways. So there are 36 ways in which the boys can sit together. Okay? There are 36 ways in which the boys can sit together. Okay? So I have shown you how we do this, right? So we are good to go. So for those that might be wondering, I think I showed you, so maybe we don't have to stress again. Now, F says, in how many ways can they sit if the boys and the girls alternate? For this one, guys, you have to be careful. Okay? For this one, you have to be careful. F, you have to be careful. So, let's say this is, okay. There are 5 people. Let's see, 5 people. 1, 2, 3, 4. 5. Boy, girl, boy, girl, boy. It's okay, right? So this must be a boy. This must be a girl. This must be a boy. This must be a girl. And this must be a boy. Okay? So when you look at this, it's very interesting. So this one here, you will say what you have. Maybe this is a boy, this is a girl, a boy, a girl, and a boy. Okay? But if you start with a girl, it will not work. Okay? So let's see. For this place, for the first place, you have 3 boys to choose from, isn't it? You have 3 boys to choose from. For the first place of the girls, you have 2 girls to choose from. For the second place of the boys, you have 2 boys to choose from. For the second place of the girls, you have 1 girl to choose from. Now, for the last place of the boys, you now have 1 place. So what is this? This is 3 times 2 times 2 times 1 times 1. What is this? This is 12, right? This is 12 ways. This is 12 ways. Someone will say this is 2 factorial times 3 factorial. Yeah, give it a shot. Right? 2 factorial times 3 factorials. Right? So this is how we roll. Okay? This is how we roll. Okay, guys? So this was the first example. We have a long way to go. Right. Now, okay. Now the second example, in how many ways can 4 maths books, 3 history books, and 3 science books, or 3 science books, and 2 biology books be arranged on a shelf? It's okay? Let's see. We have 3 maths, 3 history, we have 3 science, 4 maths. Thank you. It was 4 maths. 4 maths, and then we also have 2 biology. Now, the first question says, how many ways can we arrange them on the shelf? How many books do we have in total? In total, we have 7, 10. It seems like we have 10 books. Right? It seems we have 12 books, not 10. We have 12 books. So we can arrange them in 12 factorial ways. Okay? We can arrange them in 12 factorial ways. So let's take our calculator. This is 479,001,600 ways. Okay? 479,001,600 ways. Okay? This is how we can arrange them on a shelf. Right? This is how we can arrange these books on a shelf in 12 factorial ways. Number B. How many ways can we arrange these books if they are to be arranged on a shelf so that all books of the same subjects are together? Okay. So first thing first, how many maths books do we have? We have 4 maths books. So that means 4 factorials. How many history books do we have? We have 3 history books. Remember, books of the same subjects are together. Same subjects are together. Okay? Same subjects are together. Okay? So, same subjects are together. Now, what do we have? We said maths, we have 4 factorial ways of arranging them. History, we have 3 factorial ways of arranging them. Science, we have 3 factorial ways of arranging them. Biology, we have 2 factorial ways of arranging them. However, since we said we are now taking subjects of the other similar subjects together, we are grouping them together. This tells us that we have 4 groups, right? We now have how many groups? 4 groups. We now have 4 groups. So it'll be 4 history together, 4 maths together, 3 history together, 3 science together, 2 biology together, and then we have 4 ways of arranging these groups. We don't know whether to start with history or to start with maths, science, or biology, right? Hence, we have this extra term to say we now have 4 groups to group. Okay, perfect. So let's get our answer. It is 4 factorial times 3 factorial times 3 factorial times 2 factorial times 4 factorial, right? Times 4 factorial, which is, oh no, which is 41,472 ways. So when we want to group subjects of books of the same subject together, we have 41,472 ways of grouping, of arranging books of the same subject together. Okay? All right. Perfect. Now, example 3 says, how many ways can 4 maths books, 3, okay, it seems I am repeating this, so I'm going to skip. Maybe let me erase it. Yeah, I'm skipping it. Okay, so I guess this is it. Yeah, this is it. This is it, guys. This is it for our lesson. Yeah, this is it for our lesson. So I hope this is working. All right, I hope this is working. This is what we do when we arrange objects in a row. Okay, this is what we do when you arrange objects in a row. Okay, this is what we do. So with that being said, it's a wrap, and I hope you will enjoy this and excel. If you have questions, remember, you can email us, or you can chat with us on WhatsApp, or comment on YouTube, and we will try to respond. So that is it. Bye bye. Okay. Sorry guys, we did not see this question. So we will join this video to the video made earlier. So the 4th example, and remember, this must be the 2nd. It was the 2nd. So this must be the 3rd. Okay, this must be the 3rd. Okay, this must be the 3rd. Okay, so this will be our 3rd. So the 3rd will be, it says, find the number of ways in which 6 people can ride a toboggan. I don't even know what is that. If one of a selected 3 must drive. So this question, we chose it because it's interesting, and trust me, it's interesting. So we have 6 people that we have to choose from. Okay. However, there's a 3 that must drive. So to drive, let's say this one here is to drive. Only 3 people must be chosen to drive. Okay. However, one of the 3, not 3, one of the 3 must be chosen to drive. Okay. Now, if one has been chosen to drive, how many do we have left? We have 5, we have 4, we have 3, we have 2, we have 1. So to answer this question, it means we have 3 people multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. Or alternatively, which is, maybe let's just do it. Alternatively, I'll explain it. We have 3 times 5 times 4 times 3 times 2 times 1, which is, we have 360 ways in which 6 people can ride a toboggan. Or you can say you have 3 times 5 factorial. Okay, you can say you have 3 times 5 factorial. Be careful. This 3 is not a factorial because you're only choosing one. Okay, you are only choosing one of the 3. You are not saying one will be here, another will be there. No. You are only choosing one of the 3. Okay, so when you try this one as well, it'll be 3 times 5 factorial, which is 360. 360 ways. Okay, it'll be 3 times 5 factorial, which is 360 ways. So this is it, guys. I hope you guys enjoyed this lesson. So with that being said, it's now officially a wrap. So bye bye.